Addition of more than two vectors using algebra now. Okay, so we had two vectors. We were playing with two vectors, and we were combining the two vectors, and we were getting resultant out. And the easiest way was two vectors, you draw resultant, it makes a triangle. Once you got the triangle, you got your sine cosine law. So adding two vectors is relatively easy. What if you've got more than two vectors? It means that there's no triangle then. Yes, what you can do is you first add the two vectors together, draw a triangle, get the resultant out, and then with that resultant you add the next vector, make a triangle, get your resultant out, and then you keep on doing this. Okay, so it takes quite a time, but it is the right way. Okay, but there's an easy way of just resolving or adding vectors more than two, and that's the algebra method. So what we've got here, you've got three vectors. Okay, what I can do, as I said, I can let me go back here. If I look at this vector here, I can draw its two components. That's this one here and this one here. So I've got one vector in the positive x and the other vector in the positive y. So I split my f1 into two. I can split f3 here and here. Okay, so my f3 is also divided into two components, x and y. My x component is positive. My y component is also positive. Okay? No, it's not positive. Use your brains. My y component is negative, it's pointing downwards. My x component is positive because it's directed towards the positive x. Now look at f2 then. For f2, I can do the same. I've got this component and I've got this one. I've got my y in positive, but I've got my x in negative. So what I've got, I had three vectors. I divided each vector along the axis, x and y, each vector, okay? So it shows you here, you've got the three vectors and their components. As it says here, the steps, I'll go through it also. Define your axis first. Doesn't mean your axis have to be horizontal, vertical. Your axis can be in any rotation, but the two lines have to be perpendicular. But to visualize, we draw horizontal and vertical lines. Step 2 is to resolve each force into its axis component. Okay, each vector along x and y. Step 3 is to add all the x components together and all the y components together. These two total become resultant vector. Simple as that. And then to find the magnitude and angle of resultant. For magnitude, you know what to do. You go to Pythagoras theorem. And for the angle, you use mostly tangent, and you can get your angle out. But let's have a look. So what we've got here, we have our F1, F2, and F3 vectors. That's here. If I look at F1, I've got its component here. No, sorry, that's the component of F1. So I've got F2 components here and F3 components here. I sum them up. So I add all x components together. That's here. And I add all the y components. So in the end, I've got my x and y component. So in simple words, what I will have, for example, if this is my resultant, I've got my x component, I've got my y component. So this is 90-degree, remember? You can get this out easily. So I won't go into the details, you know how to do this. And once you got this, you got your angle out. Okay, so the mistake being made by a lot of engineers is that I've got this here. I've got is two components. This one, which is this one here, and this one, which is also here. If I find tangent of it, will it be this angle or this angle? Which one? Two components I've got, x and y. I want you to find the angle. You use tan. Am I right? So which angle would it be? Theta 1 or theta 2? Why theta 1? Say again? Yeah. Yes, you're right. If I take those two components, okay, and what's tan? Perpendicular over base. That's y over x, am I right? Y over x. So that means the angle is this one. If I take this one, then it becomes x over y, am I right? So it just depends. Remember which components you're considering, and that angle will come out. Okay, so if you find this angle, it means you subtract 90 and then you'll get this one out.